Alright, child class, almost done with Unit 9, okay? Hang on there. Multi-level inheritance. So we'll look at another example. So here in our main program, we start with a printout. Then looks like we create an object cat, and it's from the cat class. Before we read any further, let's go ahead and peek into the cat class. So I can see my cat class right here. And if I look in my cat class, it looks like it's an extension of mammal. Awesome. So I'll look where my mammal is. Well, my mammal is an extension of animal. Now it looks like we are reaching levels of inheritance here. And if I look at animal, well, that is an independent class. So look at what's happening here, you guys. So we have animal, which is an extension of mammal. Then cat is an extension of mammal. Okay, so this is multi-level inheritance. So if you look at this, and now as soon as I declare this object class, remember, it's always said that your superclasses constructor is always invoked first. So let's start looking at their constructors. So classes, so cat's constructor looks like I'm initializing type to be tiger, and I'm doing system.out.println cat constructor call. Then I'm looking at mammal's constructor. I initialize weight to be 500, and I do system.out.println mammal constructor call. And in animal, I'm initializing age to be 15 and animal constructor called. So as soon as I create this object, you guys, whose constructor will be called first? Superclasses. So I should expect animal constructor called, mammal constructor called, cat constructor called. Okay, because that's the level of inheritance. Then I do println, then I do animal type is equal to cat.getType. Cat.getWeight and cat.getAge. So cat.getType, meaning I'm printing return type, and type is initialized to tiger, so I should see tiger. Then I do cat.weight. So because cat is an extension of mammal, I can inherit the weight attribute, right? And weight looks like it was initialized to 500, so I should get 500. And I do cat.getAge, and because this is all a level of inheritance, mammal inherits animal, so that means even cat can access age. So get age gives me cat can access age, and age is initialized to 15, right? So my output would be something like animal constructor, right? Mammal constructor, cat constructor, tiger 505. This looks a little odd. I think this is a mistake because it should be 15 here because my age is 15 here. Okay, moving on. Multi-level inheritance and multiple inheritance. The previous program showed an example of multi-level inheritance. Animal, mammal, cat. Multiple inheritance is something different. It occurs when one subclass inherits from two or more superclasses. This feature is not available in C++. This feature is available in C++, not available in Java. Let's just look at a flowchart example of this. So you have animal, mammal inherits animal, dog inherits mammal. I don't know how to say this. I'm going to butcher this name, but I'll still try. Terrier inherits dog. So that's your multi-level inheritance. What is multiple inheritance? Like reptile and extinct like dinosaur inherits reptile and extinct. This is multiple inheritance. This is in C++, not in Java. This is the only thing that's there in Java, okay? Multi-level inheritance. Now let's look at another example. This is in another kind of a software, you guys. So it's a little more graphical, so it'll just help us clear things up again. So imagine this is called the actor. And if I right click on the actor, right, you will see all the methods available from the actor class. These are all the methods from the actor class, okay? Now, what happens is, if you click on the bug object, you will see all of the bug methods, but you will also see all of the methods the bug inherits from the actor. So bug is actually an extension of the actor class. So that's why these are the bug methods, and these are all the actor methods. And if I continue, right, now here is multi-level inheritance is demonstrated because an octagon bug, or a spider, inherits from bug, and bug inherits from actor. So therefore, this spider has the bug and the actor. So this is an example of multi-level inheritance. Okay, fish class case study. This is the last case study, you guys, and the last thing we'll discuss in this unit. This is a little tricky, so please hang on there, okay? So it begins very small. So again, we have this class, right? And the paint method, now this is an applet. We looked at console applications, so now this is an applet. And it looks like in the paint method, we created an object F1, which is of the fish1 class. Okay, and then we did fish1.drawFish. So remember, as soon as you create an object, the first thing that should come to your mind is constructor. Let me look at the constructor of the fish1 class. So the fish1 class, it looks like I have protected X, protected Y, and protected direction. So I have three data attributes, right? And they're all integers, and I initialize them to 500, 300, and 0. And then I do f1.drawFish. If I look at the result, let me show you guys what drawFish has. So drawFish, it's taking the graphic G, it's setting the cursor back, and depending upon the direction, 0, 90, 180, 270, it is drawing a fish basically. And because that when I invoke my constructor, my direction was initialized to 0, and my X and Y, which were the coordinates here, in my drawFish method, they were used to draw the fish. So they were like the position of the fish on the screen. And 0 is the direction, so it was pointing upwards. So that's why my output looks like this, okay? Keep this one in mind. This is the fish1 class, okay? So what they're going to do next is they're going to make a fish2 class. The fish2 class extends the fish1 class. And in the fish, so remember, because it's an extension, fish2 has access to the drawFish. Fish2, right, has access to those data members as well. Okay, so what's happening in, and because those data members were protected, that's why it has access to them. Okay, so what's happening is now in my paint, there's no fish1. I'm directly creating an object f2 from the fish2 class. This is the new fish2. And I'm doing f2.drawFish. Okay, so because I've extended from fish1, I can access drawFish. But remember, as soon as I create an object, constructor invoked. So I'm going to look at, I don't see any constructor for my fish2, but I still have a constructor for my fish1, right? And superclass's constructor is invoked first. So it's set X and Y to 500 and the direction to 0, right? And then I do f2.drawFish, meaning I still drawn the fish, so it was facing upright. Then in this public void turnFish, what am I doing? I'm putting a delay. I'm erasing the fish, so imagine that fish is gone. Then I add a direction plus equals 90, so I change that direction. And then I just tell if direction is equal to 360, set the direction to 0, but it's not because initially it was 0 and it went to 90, and then I'm calling drawFish. And drawFish, you guys, if you remember, it's this one, this long list, right? So if it was 0, it draws the fish here. If it's 90, it draws the fish here, right? So what do you think is happening here, you guys? I have drawFish, and then turnFish is going to make the fish go this way. Then further turnFish is going to make the fish point downwards. Then further turnFish is going to make the fish turn this way. So first drawFish, turnFish, right? Then the next turnFish, then the next turnFish, and the next turnFish. So I should expect something like this. And then we'll stop there because that's all that was in the paint method. You guys get that, you guys? And that animation is because of that delay. So that is your fish2. Okay, hang on there. So what it's going to do, it's going to bring a fish3 class, okay? So your fish3 class extends your fish2 class. Okay, and in fish3, what you did is you added the moveFish method, which takes in graphics G, and then what it does, it has a new X and Y. It modifies the X and Y. Remember, these X and Y, they were the data attributes for the original fish class, fish1 class, right? And because if you remember that X and Y right here, they were protected, they could be inherited, right? They could easily be accessed by fish2, and because fish3 is an extension of fish2, it can be accessed by fish3. So you're modifying that, and then you're doing drawFish, which is again a method from my fish1 class. So let's see what's happening here. I'm creating a new fish, and superclass's constructor is invoked, so it drew the fish like that. Then after that, I did f3.drawFish. So I would think it would remain like that. f3.drawFish, because there is no drawFish command that is specific to f3. So this is the drawFish of the superclass. Okay, it's f3.drawFish. Then I'm doing moveFish. So it's going to move to a new location. and then it's going to do turn fish. Then it's going to move to a new location and it's going to do turn fish. So it's going to face down. So I'm expecting that. It's going to go to a new location, turn fish. That, turn fish. Okay, you want to see that again? Let's try seeing that again, okay? So it should first draw the fish upright. Okay, then it should move to a new location and turn fish. Then the same way move to a location and turn fish. Okay, then finally, you guys, well, as you may have imagined, we have a fish 4 class, okay? What's happening in the fish 4 class? Class fish 4 extends fish 3, okay? And looks like fish 4 actually has a constructor associated with it. X equals X position, Y equals Y position, direction equals direction, and you're drawing fish. So that's your constructor. And this looks like an overloaded constructor, right? It's not your default constructor. And this is your move fish. So let's see. Fish 4 class redefines the move fish method. So it actually redefined the move fish method. Remember, this one had the move fish method, had a GXY. I actually have the ability of doing something like this, where I rewrite whatever fish 3 had. So fish 3 had a move fish. Fish 4 has a move fish. I'm overriding, or I'm rewriting that move fish method. And that's something you can do, you guys, with inheritance. Okay, where I have a new X and a new Y, and I try to draw the fish again. So I'm moving the fish again with a delay. What is the difference? Why do they want to rewrite this move fish? If they look at this move fish, in fish 3, they had a move fish which had an erase fish in it. And if you look at this move fish, it doesn't have that erase fish. So it looks like they wanted to use a lot of that fish method, but they wanted to erase, do not do the one line of it. So what do they do with it? So if we look at your main again, it initialized X position and Y position to 100, 100, set the direction to 90 this time, and it did fish 4 and it created a new object from fish 4. Okay, and it used the parameterized constructor, the overloaded constructor call. It put X position, Y position, and direction to 100, 100, 90. That means all this came and drawfish got called, right? So even with this, you guys, remember, it's your constructor calls will always be your superclasses constructor will all be called, and this will be the last thing that will be called, okay? So it looks like finally what you're doing with the fish is 100, 190, and you're drawing the fish. And then what is this? A for loop. 1 up to 8th time, and then you're going X position. It's like you're modifying the X position, and then you're calling the move fish command with a new X position. So what do you expect, you guys? It looks like it's drawing a fish now in the 90-degree angle, so it should be like that, right? And it draws the fish. Then it looks like you're calling the move fish, and the move fish now is going to offset only the X. So it's going to go like that, and without any erase fish, so that previous fish is going to be there, it's going to draw fish again. Okay, so you're going to see that 8 times. Right? 1, 2, 3, 4, 5, 6, 7, 8. The first fish was not a part of the loop, right? Because that was a part of your constructor. Then these fishes are drawn as a part of your loop. 1, 2, 3, 4, 5, 6, 7, 8. Square fish challenge. Well, this was just there. Imagine if you were to draw this. We will probably not do this lab, you guys, but y'all can get thinking about it. It says change the program so that it displays a square of fish. To make the square fit, change the number of fish on the for loop from 8 to 6. So this is an example, you guys, of if you wanted to draw something like this, instead of starting from scratch, right, you can start from you can inherit these other classes. This is just an example. They have fish 3, fish 2, and fish 1. But imagine this was a real life case, right? You need not have started all the way from scratch. You could have inherited fish 3. You could have even modified and rewritten something of fish 3 that you did not like, but still used a lot of the other things that are already there, like X position, Y position, drawing the fish. You can use all that, things of drawing the fish, and then just modify the move fish command. So this is one benefit you can use inheritance for. And with that, that is the end of Unit 9.